Hello, my darlings. Today we are going to be looking at scientific consensus. Your success goals is that by the end of this video, you'll be able to differentiate good science from assumptions and identify what the scientific consensus is on climate change. Let's get started. Now, people have lots of beliefs about many things. These are ideas that we think are true based on a number of sources, like past experiences, faith, or what somebody said. Beliefs can change as people learn and have new experiences. People also have assumptions. These are things that underlie our ideas behind beliefs. These connect evidence that we have to conclusions. Now remember that this evidence, whenever I say this time, today, that's talking about these number of sources like past experiences, what somebody said. It doesn't always mean like scientific evidence, right? Now, because of that, assumptions may or may not be based on fact. So let's look at a couple of examples of these with climate change. Now, let's say, for example, that you have the belief that carbon dioxide is one of many atmospheric gases, and it makes up a small percent of the total gases in the atmosphere. On a planetary scale, you might say, all right, it makes sense that a little increase in CO2 is no big deal. As a result, this person comes to the belief that humans are not causing climate change. We can also look at a different belief. Carbon dioxide occurs naturally in small amounts, but it's very efficient at absorbing heat energy. On a planetary scale, that would mean that a little increase in CO2 makes a huge difference, so this person comes to the belief that humans are causing climate change. So you can see how different beliefs and assumptions can lead to very, very different conclusions, even when people are starting off with similar information. So how do we know good science? Well, good scientists are going to follow a logical path to help refine our knowledge. Now, this path starts with an idea that they have, then they research that idea. They draw certain conclusions, that gets published, they get feedback on their work, which leads to future research. Now, publication isn't just willy-nilly. You're not allowed to publish whatever you want. It requires strong evidence from experiments or models, and it also requires the use of quality sources to support explanations. All scientific ideas are subject to challenge and modification, especially with time. Science evolves and it changes the more that we learn. Because of this, research results that do not agree with other results are published still, so long as they have done that good science, so long as they still have strong evidence and they're using those good sources. Over time, science is self-correcting. That means that as time passes, it fixes itself. This is because an open debate of theories allows weak ideas to be pushed out until a strong consensus is reached. What does that mean? Well, a consensus is the judgment or conclusion that's arrived at by most of those concerned. For example, adults have reached the consensus that school is important because an education allows to have a society that knows more, that can make more informed decisions, and that can be more successful over time. Now, when the scientific community comes to a consensus, this means that the idea has withstood rigorous testing, and it represents our best understanding of the subject being studied. So many people's publications and lots of research that has been done all leads to the same conclusion. Now, some uncertainty will always remain. That is not to say that it's going to be like 100%. It just means that this is what most of the research supports and says. Scientists try to minimize that uncertainty to reasonable levels. So what is the scientific consensus on climate change? Well, 97% of climate scientists combine models and other evidence to conclude the following. Earth's climate is currently warming on average. The changes are not the same at all locations on Earth. Future changes might be more rapid, happen faster, than changes from the past, and human activities are responsible for most of the climate change that we are observing. So when we say that 97% of climate scientists agree, you can kind of think about it in these terms. If you had 100 climate experts in a room, 97 of them, all these green guys, would say, yes, climate change is happening, the world is getting warmer, and humans are largely to blame. You would have 2 individuals who are like, I'm not sure. They're neutral. And then you'd have 1 single person who says, no, absolutely not, that's not true. All right? So it's a significant majority that agree on this. Now, it is important to keep in mind that climate scientists do say that climate change will not be the same everywhere. Some places will be wetter, others will be drier. Polar regions are going to be a lot more affected than tropical regions. It's going to include changes in temperature, yes, that's why in the past we've sometimes called it global warming, but also patterns and amounts of precipitation. That's like snow or rain or hail, anything falling from the sky. The amount of ice and snow cover, your sea level, and then extreme weather events. Now, this is important to note because sometimes people don't understand the fact that things aren't going to change the same everywhere, and that creates a bit of confusion. As a result, there can sometimes be this illusion of a climate change debate. If some places are affected more, it might be very clear to them that climate change is happening right now and is a big problem. But if other places are affected less, it can be a lot less clear to them. And they might say, hey, looking around, I don't see any evidence of climate change. Sometimes we see lots of evidence of climate change, but if we're thinking that climate change must be one thing, Earth getting warmer, and we see something that goes against that, like snow, we think, oh, that must not be true then. People see and remember information that matches what they already know. People have partial information and they leap to conclusions. And people often listen to influential leaders rather than figuring it out themselves by looking at science. This is why it's really important that when you're talking to other people about scientific issues, that you rely on evidence, not assumptions or beliefs or even common sense. I hear that a lot, like, oh, well, everything, like all the icebergs are melting. Okay, what's your evidence? Well, it's just common sense. It shouldn't be. As a good scientist, it's important to rely on evidence, things like models and graphs, or research and experiments. When others are talking to you, even if you're like, oh yeah, this person's really smart, still ask for credible experts or sources. Ask where their information is coming from. Is it coming from good science? Is it coming from, we talked before about a good expert? Or is it, well, I just heard it, or, oh, I just read it, or, well, everybody knows that, right? Constantly ask yourself if what you're thinking is based on science, good science, or is based on assumptions.